Welcome back to lesson about the integral test. This integral test will tell you if a series converge or diverge. It will tell you that if the integral converge, the series converge. It will tell you that if the integral diverge, the series diverge. They go hand by hand. So let's go to solve these 10 problems and let's go to review exactly what it says the integral test, that there are conditions. The function have to be decreasing, positive, and continuous. Let's go to see the integral test. The integral test say that if you have a positive, continuous, and decreasing functions, if this integral converge, this series converge. If this integral diverge, this series diverge. Let's go to apply this test to several examples. Okay, let's go to apply the integral test to this problem. This problem say determine the convergence of divergence of this series. It's always good to write a few terms of the series. The series is 1 divided by n plus 3. So when n equal 1, this is 1/4. When n equal 2 is 1/5. When n equal 5 is 1/6. 1/7, etc. So it's a part of the harmonic series. It's the harmonic series except for the first few terms. So we know that this series diverge. But the question here is to find that this series diverge because we use the integral test. What it say the integral test? The integral test say that if the integral from 1 to infinity of the function 1 divided by x plus 3 ddx, if this converge, the series converge. And if this diverge, the series diverge. So they go hand by hand. But there are three conditions for this. First condition, the function has to be positive. The function has to be positive. This function is always positive. Indeed, if I represent this function 1 divided by x plus 3, at x equal minus 3 have an asymptote, so the function will do like this. When x is 0, this is 1/3, and it goes to 0 at infinity, it will go to 0, and from this side we'll do like this. But this side is not what is interesting. This side that is interesting is from 1 to infinity. So the function has to be positive. Is positive the function in the interval 1 infinity? Yes, it's positive. Okay, it's positive. Is continuous? Well, the function is not continuous at x equal minus 3, but on the interval 1 to infinity is continuous. And the other condition is positive, continuous, and the third condition is decreasing function. Well, to know if it's decreasing, I will do the derivative respect to the x of 1 divided by x plus 3. If this is negative for all x from 1 to infinity, the function is decreasing. What is the derivative of x plus 3? The derivative respect to the x of x plus 3 minus 1 is minus x plus 3 minus 2, or minus 1 divided by x plus 3 squared. This is always positive. For x positive, from x bigger than 1, this is always positive. Even for x negative is positive. So it's minus something. So the derivative is negative. It means that the function is decreasing. Then I have fulfilled the three conditions, so I can apply the integral test. So what is left in this problem is to do the integral. So the integral from 1 to infinity, the integral from 1 to infinity of 1 divided by x plus 3 ddx. This is natural log of x plus 3, and between 1 and infinity is natural log of something that is infinity minus natural log of 4. But natural log of infinity goes to infinity, so the integral diverge. So the series diverge, and hence the series diverge. Let's go to the next problem. This problem says use the integral test to determine the convergence of diverging of this series. The series is this summation, the summation from n equals 0 to infinity, 3 minus n, or the summation from n equals 0 to infinity of 1 divided by 3 to the n, or if I develop some number when n equals 0 is 1, when n equals 1 is 1/3, 1/3 squared plus 1/3 cubed, etc. So this is clearly a geometric series, and the r is 1/3. Because the r is smaller than 1, this series converge. But the problem says that use the integral test to prove that this series will converge. So the integral test is based on the facts that, first of all, before using the integral test, you need to be sure that the function is positive. The function is positive because 3 to the minus x, the function 3 to the minus x of 1 divided by 3x, this function does like this, and is always positive. When x is 0, the function is 1, and when x is very big, the function when x is, let's say, when x is 1, the function is 1/3. Okay, and when x is minus 1, the function is 3. Okay, and the function goes to the 0 when x goes to the infinity. So it will converge the integral from 1 to infinity of 3 minus x ddx. This is the question. But before doing this, we need to be sure that we can apply the integral test. The integral test is positive function. Yes, it's positive. It's always positive. See the arrow. It's always positive. Second, continuous. Yes, continuous function. And the third condition is decreasing function. Yes, it's decreasing. So now I can use the integral test. So if this integral converge, that it will converge because I have realized that this is a geometric series, the series will converge. They go hand by hand. So what is the integral of 3 minus x? Is minus 1 natural log of 3 divided by 3 to the x, or multiply by 3 minus x. So this is when this have to be evaluated between 1 and infinity. When it is infinity, it will go to 0 plus, it will be when it is infinity, 3 to the infinity will go to the infinity, and 1 divided by infinity will go to 0. And when it's 1, it would be minus the evaluation at 1. At 1, the evaluation is natural log of 3 raised to 1. So this is a positive number because the area is always positive, of course, and it will be 1 divided by 3 natural log of 3. So the integral converge. The integral converge, the integral is not infinity. The integral converge, then the series convert, and the problem is solved. Let's go to the next. So the next problem say, use the integral test to determine if the series summation of n equal 1 divided by square root of n multiplied by square root of n plus 1 converge or diverge. First of all, we need to be sure that this function 1 divided by square root of x plus 1 is a decreasing function, is a positive function for sure, that is positive for x bigger than 0, for x bigger than 1 is positive, but also for x bigger than 0 is positive. Is decreasing function also. You can make the derivative of this function, it would be negative, the derivative. So it fulfills the 3 conditions to apply the integral test. So we do the integral from 1 to infinity of this function. If this integral converge, the series converge. So the antiderivative of this function is natural log of the square root of x plus 1. Why? Because the derivative of this function is 1 divided by the function multiplied by the derivative of a square root of x. If the derivative of square root of x is 1 divided by square root of x, and put the 2 to correct, and it will be the antiderivative. The evaluation from 1 to infinity will make natural log of a square root of something very, very big. This is very, very big. This goes to the infinity. So this series diverge. Now we use the integral test for this series. So we construct the function 1 divided by x natural log of x. And we wonder, this function is decreasing? Well, yes, do the derivative respect to the x, and it will be negative. If you want, you do it. The second question is positive for x bigger than 0? Yes, for x bigger than 1 is a positive function. So it's positive, is decreasing, and the third condition is continuous. Is continuous on the interval on 1 comma infinity. On 1 comma infinity is continuous. Yes, it's a continuous function. It exceeds the limit when x goes to x0 for every point x0 that is on this interval of the function. It exceeds and is the value of the function f of x0. So we can apply the integral test. So the integral test, I make the integral forever. If you can do from 3 to infinity, from 4 to infinity, a few terms will not make any change. From 10 to infinity, if you want, of 1 divided by x natural log of x ddx. If this integral converge, the series converge. What is this integral? The integral is natural log. What is the antiderivative of 1 divided by x natural log of x? Is the natural log of the natural log of x. Why this is the antiderivative? Because if you make the derivative of this function, you will obtain this function. So you make the evaluation between 10 and infinity. It doesn't matter if it's 10 or 2 or whatever. And this is natural log of the natural log of infinity minus natural log of the natural log of e. Maybe we do between e and infinity. Natural log of e is 1, and natural log of 1 is 0. Oh, so this would be 0. And natural log of infinity, the natural log of infinity goes to infinity because the curve does like this. It goes like this. At 1 is 0, it goes to minus infinity when you approach to 0, and it goes to infinity when x is very, very big. So natural log of infinity is infinity, and the natural log of infinity is also infinity. So the integral diverge. So the series diverge. Let's go to the next problem. Say determine the convergence or divergence. So we do the same thing. This is a convergence series. What we do the integral test. The integral test will say, is the function 1 divided by x 5/3 is positive for x positive? Yes. Is always positive, this function, and it will do x, it will do something like this. So it will be positive, it will be decreasing, and it will be continuous. So I can apply the integral test. So the integral test say, make the integral from 1 to infinity of 1 divided by x 5/3 dx, and see if this integral converge. If this integral converge, the series will converge. So what is this integral? This integral is the integral from x minus 5 divided by 3. So it will be x minus 5 divided by 3 plus 1 divided by minus 5 divided by 3 plus 1. What is that? This is x minus 5 plus 3 is minus 2/3 divided by minus 2/3. So this is equal to a minus 3/2 1 divided by x 2/3. And this has to be evaluated between 1 and infinity. So it will be minus 3/2 1 divided by x something to the infinity 2/3. This limit, when you go to the infinity, this will go to 0. Minus minus plus 3/2 1 divided by 1 to raised to the 2/3, that is 1. So the integral will be 3/2. So if the integral is 3/2, it converges. So because the integral converge, the series converge. So the integral test is useful to analyze if the series 1 divided by x or 1 divided by n converge or diverge. How you will know? You will construct the function 1 divided by x. It's a decreasing continuous function, a positive function, 1 divided by x, 1 divided by x. 1 divided by x is, for positive values, is positive decreasing. So the integral from 1 to infinity of 1 divided by x ddx, this is natural log of x. When you evaluate between 1 and infinity, this is natural log of infinity, which goes to infinity minus natural log of 1, which is 0. So the integral of 1 divided by x of 1 divided by x goes to the infinity, so diverge. So the series summation from n equal 1 to infinity diverge. So when you have the series summation from n equal 1 to infinity of 1 divided by n squared, these converge. Why it converge? because if you do the integral of 1 divided by x squared d dx from 1 to infinity, this will be the integral of x minus 2 d dx will be the result from 1 to infinity. The result will be x minus 2 plus 1, x minus 1 divided by minus 1. Or it will be 1 divided by x minus 1 divided by x, evaluate between 1 and infinity. So it will be minus 1 divided by something that goes to the infinity minus 1 divided by 1. So when x goes to infinity, 1 divided by infinity will go to 0. So this is positive 1, so converge. So the p series is converge. So what we can write is like this. The integral of 1 divided by x p dx converge if p is greater than 1. So it means that the integral of 1 divided by x squared converge, or 1 divided by x3 half d dx converge, or the integral of 1 divided by x fifth d dx, all these integral converge. And so the related series, like summation from n equal 1 to infinity of 1 divided by n squared, or summation from n equal 1 to infinity of 1 divided by n 3 half, or summation from n equal 1 to infinity of 1 divided by n 5, all these series converge because of the integral test. Remember that all these functions, 1 divided by x squared, 1 divided by x3 half, and 1 divided by x5, they are decreasing positive and continuous function when x is positive, of course, on the interval 1 to infinity is positive. What happened with the integral of 1 divided by x 1 half, for example? This integral diverge. So why? Well, we did it. We did it with x 5/3. 5/3 is converge because it's bigger than 1. So what happened with this integral, x 1/3? Well, the integral, this diverge because the integral of 1 divided by x to the p d dx converge if p is greater than 1. Diverge if p is smaller or equal than 1. So this is the conclusion for the p series. So let's go to the next problem. The next problem says determine the convergence or divergence of the series n 2/3. 2/3 is smaller than 1. So diverge by the p series, because the integral of 3 times 1 divided by x 2/3 d dx from 1 to infinity, this integral diverge. You can do the integral, and you will see that it will diverge. The next one, determine the convergence or divergence of this series. Well, this function is true, is positive. When x is positive, the function x plus 2 divided by 5x plus 1 is positive. It has here an asymptote at x equal 1/5 minus 1/5. It would have an asymptote. It will do like this. But when x is bigger than 1, this is positive, decreasing, continuous from x equal 1 to infinity. So on the interval 1 to the infinity, I can apply the integral test. So will I do the integral of x plus 2 divided by 5x plus 1 ddx to see if it will diverge, or I will pay attention to one fact, that is that the a sub n doesn't goes to 0 when n goes to infinity. The a sub n doesn't go to 0 when n goes to infinity, because the limit when n goes to infinity of n plus 2 divided by 5 and n plus 1, 5, or whatever, is 1/5. You can do this limit dividing by n here, divide by n here, divide by n the numerator, and divide by n the denominator. And the limits of the a sub n term when n goes to infinity doesn't goes to 0. So for the divergence test, this series will not converge. For the integral test, can I prove that this integral from 1 to infinity will diverge? Yes, but it's more work to do. You just can do the test for divergence, and the integral cannot converge. Let's go to the next problem. The test problem say determine the convergence of divergence of this. So this function is positive, continuous, and decreasing. So but it's positive after x bigger than 2. It doesn't matter if it's after x bigger than 10. It doesn't matter. A few terms of the series will not change the convergence or divergence. So you can choose this point wherever you like. So this function is positive, continuous, and decreasing, so I can see if the integral converge. If the integral converge, done, the series converge. What is the integral from 2 to infinity of this function, of the function 1 divided by x natural log of x squared? What is the antiderivative of this function? The antiderivative is the function whose derivative is this function. What is this function? Minus 1 divided by natural log of x. The derivative of this function is this function. You can do it by a change of variables. You can make this integral like this: natural log of x equal u. So the derivative respect to the x of natural log of x is the derivative of u respect to the x, and the derivative of natural log of x is 1 divided by x, is the derivative of u respect to the x. So the integral from 1 to infinity of 1 divided by x natural log of x ddx, because ddu is 1 divided by x ddx, this is ddu, and this is ddu 1 divided by x. So this integral will be the integral of ddu multiplied by 1 divided by natural log of x. 1 divided by u, because natural log of x is u. Okay, 1 divided by u. And what is this integral? This integral is equal 1 divided by u by natural u is natural log of u. So what is u? U is natural log of x. So this integral, the integral from 1 to infinity of this function, is u squared, is u squared. Sorry. So it's ddu is 1, ddu is here, is u squared. So the integral of u squared is the integral of u minus 2 ddu, is the integral of u minus 1 divided by minus 1, or minus 1 divided by u, or equal to minus 1 divided by u, but u is natural log of x. So what is the integral? The integral between 1 and infinity, you can keep going, and it will be 1 divided by natural log of 2. So the fact that this integral converge makes possible to say that this series will converge. So the series converge. Now the last one is this one, natural log of n divided by n cubed. Will converge or will diverge? Well, the first thing is to be sure that the function natural log of x divided by x cubed is positive, continuous, and decreasing. If we are sure, that is easy to see that is positive because natural log of x is always positive if x is bigger than 1, and x is positive if x is bigger than 0. So for x bigger than 1, this function is positive, is continuous, and is decreasing. I can see that the derivative of this should be negative. You can do the derivative of this function and prove it that is negative when x is bigger than 2. So if we do integration by parts, we can do the integral of f of x ddx of natural log of x cubed ddx, and we can prove that this integral is a number, is fixed, is not infinity, so it converges. And because it converges, the series will converge. And the problem, I hope so, is sine of n divided by n. So it will converge or it will diverge. This integral you cannot apply the integral test because the function is not decreasing. When n equal 1, sine of 1 radian, is positive. When n equal 2, sine of 100 and something is positive. When n equals 3, sine of something is positive. But when n equals 4, sine is negative. So it starts to be negative and positive. So this is an alternated series. But it's sine of x divided by x squared. So this will make something that was negative to be positive. So sine of x, let's go to y equal x is this function. Sine of x, sorry, let's go to do it like this. Sine of x is this function. And 1 divided by x, let's go to represent this function. 1 divided by x, sine of x. Well, sine of x is this function. 1 divided by x is this function. So I know that the limit when x goes to 0 of sine of x divided by x by L'Hopital rule is 1. So the function sine of x divided by x is something that will do like this. Here, sine of x divided by x will do like this, will do like this. So this oscillation square will go like this. Sine of x divided by x, it will start at 1 square, and later on we'll do like this. This is the function sine of x divided by x squared. Check it in a graphing calculator to see if it's true. So the function is always positive, but it's not decreasing. Sometimes it's decreasing like this, sometimes it's increasing like this. So you cannot apply the integral test to know if this series is converge or diverge, because to apply the integral test means that the series, that the function have to be decreasing all the time, decreasing. So what is this one? What is this series? The summation from n equal 1 to infinity of sine of n divided by n squared. Well, when n equal 1 is sine of 1 divided by 1 plus sine of 2 square plus sine of 2 divided by 2 square plus sine of 3 divided by 3 square. It converge or it will diverge? What test we can use? Wow, let me think what test I will use. If I think about the divergence test, I will look for the a sub n term, sine of n divided by n square, and I will do the limit when n goes to infinity. If this limit of a sub n doesn't go to 0, the series diverge. But in this case, when n goes to infinity, sine of n is a number that is between 1 and minus 1, so the n will go to infinity, n squared will go to infinity, so the a sub n goes to 0. So this will not, the divergence test will not say me anything because a sub n goes to 0. Okay, what other test I can use? Oh, what other test? Well, sine of n is smaller than 1. So I would say sine of n squared is smaller than 1 squared, which is 1. Okay. So this is smaller than 1 divided by 1 square plus 1 divided by 2 square plus 1 divided by 4 square. Okay. Plus 1 divided by 2 square, 1 divided by 3 square, plus 1 divided by 4 square. But this series is 1 divided by n square. This is the summation from n square. And these converge. So I found that this series converge. So sine of n divided by n square is smaller than the summation is smaller than the summation of 1 divided by n square. So the a sub n is smaller than the v sub n, term at term. So the v sub n converge because 1 divided by n squared converge. And this is a sub n is smaller than 1 that converge, so converge. So I have proven that this series converge, but I have not proven using the integral test. I have used the comparison test to prove that this series converge. Okay, this is all, and see you on the next lesson.